Hi everyone, we're looking at drawing and interpreting real life graphs. Page 463. The distance time graph given shows Olivia's 3-hour journey. We're going to dive straight into this question. How far does Olivia travel in the first hour of her journey? So that's, if you come along to the x-axis, time in hours there is 1 hour. How far has she traveled? Here's distance on the y-axis. She's traveled a distance of 30 kilometers in the first hour. For how long was she stopped? She stops then for 1 hour. So you can see she stopped because her distance isn't changing anymore. Okay, she's 30 kilometers here. She still traveled 30 kilometers from home here. She's still 30 kilometers from home here. Another way of saying that is the slope of that line is 0. So she's not moving. How far did she travel in the third hour between 2 and 3? She traveled a distance from 30 kilometers to 75. So that's a total distance of 75 kilometers. To point out that that distance is also the rise and that time is also the run. So if you want to know her speed there, 45 kilometers in 1 hour, that's 45 kilometers per hour. So just to point out the slope of these graphs gives the speed. Okay, quickly look here, what's the slope in the first hour? Rise over run, distance over time. Distance of 30 kilometers, time of 1 hour, so 30 kilometers per hour. What was the total length of the journey? 0 to 75. She traveled 75 kilometers in total. Having looked then at question 5, this graph indicates the distance a cyclist must travel to work. Use the graph to determine the distance to work. So here's home, here's work. Okay, right up here at the end, 12 kilometers is the total distance to work. The time taken to get to work is along the x-axis here, 0 to 26, not 28, just right there, 26. The distance traveled after 10 minutes. So after 10 minutes, between 8 and 12, there's 10 minutes. How far has this cyclist traveled? Well, that's this point here. So what's the value? Somewhere between 4 and 5. Okay, probably 4.5 kilometers. After 17 minutes, you're up here. That is 9 kilometers and a bit, maybe 9 1/3 kilometers. Time taken to travel 6 kilometers. There's 6 kilometers there. How long did it take to get 6 kilometers from home? It took 14 minutes, between 12 and 16 minutes. Okay, go across and down. 11 kilometers. How long did that take? Up here at 11 kilometers, between 10 and 12. Come across to here. There's 11 kilometers. Took 20 minutes. The average speed for the whole distance, excluding this 2-minute stop here, okay, during this period where the slope is flat, the cyclist, she wasn't moving. How long did that take? Well, the average speed is distance over time, and our distance, we said, was 12 kilometers, and it took 26 minutes with a 2-minute break. So our average speed, and this is not the speed at any particular time, just the average speed is the total distance or total time. And for us there, that was 12 kilometers. Now, 26 minutes to work minus the 2-minute break, so that's 12 kilometers over 24 minutes. And that's an average speed of 0.5 kilometers per minute. And that's an appropriate unit, kilometers per minute, to use for speed, or you could use kilometers per hour if you wanted to convert. I am going to ask you now to go to page 462 and do questions 1 and 3 before class. All right, thank you.